My name is Dr. Marcus Webb, Senior Signal Analyst, Deep Space Listening Array, Luna Far Side. For 32 years, I've been listening to the universe, pulsars, quasars, the cosmic microwave background, the dying whispers of stars older than our solar system. I've heard it all, but nothing prepared me for what we received on March 9th, 2186. A signal from Kepler-186f, 500 light years away. And it sounded like a human voice. Kepler-186f. You probably don't remember the name. It made headlines back in 2014 when we first discovered it. An Earth-sized exoplanet in the habitable zone of its star. The first of its kind. For a few months, everyone wondered, could there be life there? Could someone be looking back at us? Then we found 1,000 more exoplanets, and Kepler-186f became just another catalog entry. Just another world we'd never reach. 500 light years. Even our radio signals, traveling at light speed since the 1930s, wouldn't arrive there until the year 2430. And any reply wouldn't reach us until 2930. A 1,000-year conversation. Except, that's not what happened. The signal came in at 3:47. I was alone on the night shift. Just me, the hum of the equipment, and the silence of space. At first, I thought it was interference, a satellite, maybe even a prank transmission from one of the Mars stations. But the directionality was wrong. The frequency was wrong. And when I triangulated the source, my blood went cold. RA 19 hours, 54 minutes, 36 seconds. December plus 43 degrees, 57 minutes, 18 seconds. Kepler-186f. Exactly. I ran it through every filter we have. Stripped away the cosmic noise, the redshift, the interference from 500 light years of space dust and radiation. And what was left shouldn't have been possible. A voice, modulated, compressed, but unmistakably linguistic. Someone was speaking, and they were speaking in a pattern that resembled human phonetics. But here's what made it impossible. The signal's temporal signature was wrong. According to our best calculations, this transmission was sent approximately 230 years ago, around the year 1956. Decades before we discovered Kepler-186f. Decades before we'd sent anything coherent into deep space. They couldn't have been responding to us unless they heard us first. I called Director Okoye immediately. She didn't believe me, not until she heard it herself. Within 6 hours, the entire facility was awake. Linguists, cryptographers, xenobiologists, even a team from SETI Earthside. We played the transmission 200 times that first day. Some heard words. Others heard music. A few thought it was just pareidolia, our brains finding patterns that aren't really there. But I knew better, because 17 seconds into the transmission, something happened. We heard a pause, a deliberate pause, and then, clear as anything, a breath. Let me explain something about signals from deep space. When you're listening to a pulsar, you're hearing the physics of a rotating neutron star. Mathematics, pure and simple. When you hear background radiation, you're hearing the echo of the Big Bang itself. Impersonal, ancient, dead. But this had timing, cadence, emotion. Whoever sent this, they were trying to communicate, and they were alive when they sent it, 230 years ago. We spent 3 weeks analyzing every second of the transmission. Dr. Ifeoma, our lead linguist, was the first to crack it. She isolated repeating phoneme clusters, mapped them against linguistic universals, cross-referenced with every known human language, extinct and living. The result was impossible. The signal wasn't in a language. It was in fragments of dozens of languages. English, Mandarin, Swahili, Hindi, Russian, Arabic, all woven together, distorted, but recognizable. Like whoever sent it had learned human speech from listening to us. But how could they have heard us in 1956? Our earliest radio leakage would have only traveled 16 light years by then. Kepler-186f is 500 light-years away. The timeline made no sense until Dr. Kovacs from the Quantum Physics Division proposed something that changed everything. Kovacs' theory, localized gravitational lensing. Somewhere between Earth and Kepler-186f, there's a massive object, maybe a black hole, maybe a neutron star cluster, warping space-time so severely that it created a temporal fold. Our earliest radio transmissions from the 1930s and 40s didn't travel in a straight line. They curved through this fold, arriving at Kepler-186 for decades, maybe centuries earlier than they should have, and their reply followed the same path back. A cosmic shortcut, a wrinkle in space-time that turned a 1,000-year conversation into 230 years. We're still searching for the object. We haven't found it yet, but the math works, and it's the only explanation that makes sense. Then came the translation. Dr. Ifeoma presented it in a closed session. No press, no public release, just us. She played the cleaned audio, and beneath it, her synthesized translation scrolled across the screen. I'll never forget the words. We heard you, across the dark, across the time. You called out. You asked if anyone was listening. We listened. We learned your words, your songs, your mathematics, your hope. By the time you hear this, we will be gone. Our star is dying. Our world is ending. But we wanted you to know you were not alone. You were never alone. And neither were we. 230 years ago, someone on Kepler-186f heard us. They heard our first radio broadcasts, our music, our voices leaking into space, asking the oldest question, is anyone there? And they answered. But their answer took 2 centuries to reach us through a fold in space-time we didn't even know existed. And by the time we received it, they were already gone. Director Okoye asked me what we should do with the signal, whether we should release it, tell the world. I told her I didn't know. Because how do you tell humanity that we were heard, but too late? How do you explain that someone reached across 500 light years through a crack in reality itself to say goodbye, and we weren't there to answer? We're still analyzing the rest of the transmission. There's more data embedded in it. Mathematical constants, chemical formulas, maybe even star maps. They left us everything they could. A final gift from a dying world. But the part that keeps me awake at night isn't the science, it's the end of the message. The last 7 seconds. We almost missed it. Dr. Ifeoma isolated it yesterday, enhanced it, cleaned it up, and when she played it back, we all heard it clearly. A single word, repeated 3 times in English. Thank you. Thank you. Thank you. We're preparing a response, a transmission back to Kepler-186f. If Kovacs is right about the gravitational fold, it might arrive in 70 or 80 years instead of 500. But no one will be alive to hear it. We're sending it anyway, because they need to know that we heard them, that we understood, that their voice, their last desperate message through a tear in space-time, mattered, that they weren't forgotten. This is humanity. From Earth, solar system, Milky Way. We received your message 230 years after you sent it. We heard you, and we're sorry we couldn't answer in time. You asked if anyone was listening. We were. We are. You were not alone. You will never be forgotten. Thank you for reaching out. Thank you for reminding us why we look up. Goodbye. I don't know if the universe has a memory. I don't know if consciousness survives the death of worlds. But I know this. 230 years ago, someone looked up at their dying sky and thought of us. They didn't curse the darkness. They didn't surrender to despair. They reached out, one last time, through a crack in reality we didn't know existed. And we heard them.